Make sure I got like final limit only dropping 1 point.
Yeah. It's going to be about it. It depends on what your average is. Does that make sense? If you have, let's say you have a 75% test average in here, and you make a 70 on the block exam. Okay? You make a 70. Is that going to drop your grade?
Yes.
Maybe a point, or maybe half a point. Does everybody understand? Now, let's say you got a 75 average in class and you make a 90 on the block exam. Then your grade will probably go up maybe 3 points. Does everybody understand? Because the block exam is only a fifth of your grade. It's like 20% of your grade. Okay? So, here's what it can do for you. Let's say your average in class is like 78, and you make over a 90. What could this bump up to? A B. Okay, now if you get pretty close, like a 79.4, and I'm looking at grades, and I see a 79.4, and I feel like you've done a good job, I'll probably bump you up to the next letter grade. Everybody okay with that?
Yeah.
Okay, but if you've been a clown and you've been silly, and you haven't worked hard, okay, and you've been difficult all year, okay, then it's probably not going to bump you up. Any questions? You guys good with that?
Yeah.
Anybody got a problem with that? Everybody say it now. Okay. All right. I'm going to try to go on. I'm not going to try to go real fast, but I'm going to stay at a steady pace. We're probably going to work about 27 problems today, and then work the rest tomorrow. You guys all right with that?
Yeah.
Okay. So this, again, my plan is to turn this in like a regular assignment for a regular grade. Should be an easy grade if you copy everything down. Tomorrow, we don't have very many problems. It won't take very long. My plan tomorrow is to give you another sheet that's similar to this one. Okay? And it's going to end up being a bonus. Okay? So you'll have one similar to this one, it'll just end up being bonus. All right. Get to it. On these problems, okay, you're just going to, DJ, stop. You're just going to apply your property rules of exponents. All right? So the first thing, if you notice, you got an exponent on the outside, which is a power of a power. We're going to do that last. Let's take care of everything inside first. The first thing that I need to find, what, DJ?
Oh, I was going to do the first part. Are you doing all of the work?
That was my plan. The first part you need to look for is you need to find similar bases. Okay, what are my bases here? I got A and A right there. Now, is there a plus or a minus sign in between them? No, so I can just apply my product of a power rule, right? Okay, so if I got a base and a base there, what do I do with the exponents? I add them together, right? Okay, so I'm going to write everything else. I'm going to put 2 in the front. My A would be to the 0 power. Okay, write it down. You guys need to write as I'm writing if you want credit. And then I'm going to bring my B to the 3rd down. And then put the exponent on the outside. Now you guys should know at this point that anything to the 0 power, no, not 0, it's 1. 2 times 1, it makes a difference, right? Because 2 times 0 is 0. This would be 1, so 2 times 1 is 2. I'm going to bring my B to the 3 down, and then 3 exponents. Okay, now I need to apply my power property. Does the 3 go on the 2 and the B3, or just all of it?
2.
So it's going to go on that one, and it's going to go to that one also. 2 to the 3rd power, and then B, what's 3 times 3?
9.
Okay, so 2 to the third would be what?
8.
That ends up being my answer. Remember, make sure you got all that written down. That's what I'm looking for. Okay, if you want credit, that's what I need to see. Okay, on the next one, you got kind of a fraction here. You got a top, a numerator, and a denominator. Is there anything I can do on the denominator? Like simplify it or anything?
You can bring the -1 to the top.
Yeah, let's wait to do that later, okay? Let's move things at the end. What about the numerator? Can I simplify it a little bit before I get started? Right, I got a base and base there that are the same, so what do I do with the exponents? Just add them together, right? Okay, so I'm going to bring my 2x cubed down times, what's 4 times 2? 8y to the -1. Good. Okay. I can't simplify. I can, but I'm going to wait till later to do that, okay? What can I move here? Or what should I move? That's a negative, right? Take it to the bottom. So it loses negative, right? What about, now would I take the 8 with it? No, because the negative's not on the 8, it's just on y. Same thing right here. I'm going to move that to the top. Okay, so I get 2x cubed times 8 times x to the first. 4y cubed y to the first. Okay, so multiply all this. 2 times 8, 16. I'm going to come up here. X to the fourth. And then 4y to the fourth. 4 on itself once, so we'll go into that 4 times. So my answer ends up being that right there. Pretty simple, right? I think you find out that most all these are pretty simple. Okay, where are my bases at? Y, right? Okay, now, this was a little funky because what's the exponent here? It's what? It's actually 1. The problem is, I've got a fraction right here. Okay, so for me to be able to combine these two, or add them, I got to turn this 1 into a fraction that has a denominator of what? 4. You guys understand that? So what can I turn that into? No?
4.
Good. Who said that? Good. 4 over 4. That still equals 1, doesn't it? But now it has a denominator of 4. So 4x, 3 over 2, y bases. Okay, so add the exponents. What do I add? Which is 9 over 4. And then bring my 4x 3 halves. Or anything else I can do? No. Okay, now, one thing, okay, that I want you to understand. Can I write this a different way? Okay, even though this is right, your answer choices may not look like this, right? You could have this answer also. Okay? Now basically all I've done is what? I just switched them, didn't I? Or flipped them. It's still the same answer. Okay, but it looks different. Don't get fooled on, you always got to pay attention and watch for that on multiple choice tests. Okay? Alright, next one. Still got y to the first. And I got another y over here, and I got a y inside. I'm going to rewrite this, y to the first. And then in parentheses, I'm going to go y2 over 1. Okay, so now I can go ahead and evaluate these. This is a power of a power, which is basically you're just distributing the exponents. Okay, so 1/2 times 1/2 would be what? 1/4? Yeah. Okay, and then y2 over 1 times 1/2 would be y2 to 2 over 2. What is that going to simplify to? 1. I don't want to do that right now because here at the end I've got what? I got a fraction for an exponent, right? So what am I going to have to do with these two? I'm going to have to change them, aren't I? Okay, so what would I change this to?
3 over 3.
Good. Okay, and then x 1 over 4. Okay, how do I change 2 over 2 to get a denominator of 3? Wouldn't it just be 3 over 3?
Yep.
Okay. X squared. Now, I need to change that. Okay, I gotta change this x squared to x to the 4th. What would that end up being? It's got 2. I need a denominator of 4, so it would be what?
8 over 4.
Very good. 8 over 4. Okay. Logan, you writing this down?
Yes.
Okay, so I'm going to base. So I'm going to add those together, which gives me y. 3 plus 3 is 6, plus 5 is 11. 11 over 3. And then you got an x and an x. That would be x to the 9/4. Or I could rewrite it as x 9/4, y 11 over 3. Guys need any more time with that? Or are you good?
On the y's, did you say that because all we're doing is adding
Right.
electrons, right? So you have to have a common denominator. So you could add the...
Yeah, that should have been 3 over 3. I erased it somehow. That makes sense? Because it went from 1 to 3 over 3. I just didn't write the whole 3.
Yeah, so
Well, I mean, you got a 3 there, a 3 there, and a 3 there.
okay.
Right.
Since the y in the middle was 2 over 2, I was overthinking. That makes sense.
Yeah, I mean, 2 over 2, I
2 over
mean,
2
it's still equal to 1, right?
That's what.
So if I want to, yeah, 3 over 3, that's still equal to 1, so it's still the same.
Okay. Alright.
That's why I can get away with it. Okay. All right, real simple. Write an exponential form. Okay, that means what form is it in right now?
Radical.
Radical. That's the radical symbol. I want to change it to exponential. That means I need a exponent, right? So I'm going to bring my 6 to the end out. I'm going to put it in parentheses. Keep it together. Okay, and then 4 over 3. Okay, now notice the whole thing, the reason why I put it in parentheses is because this whole thing is what? It's in parentheses. Everybody clear on that? Real simple. Number 6, okay, it'll go from, I need to change the radical form, so what would I start with? Start with the radical sign. The 3 goes there. I'm going to put the whole thing in parentheses. 4b goes there. 5 goes there. Pretty easy, right? Okay, simplify. Alright, so going to take both of those rules that we just applied, we're going to apply them to this one. Here's the first thing that you need to do. I need to take this 36 and this p to the 6 and pull them apart. And the reason why I can do this is because it's all what? Multiplication. I'm still showing the multiplication right here. Okay? All right. First thing I want to do to evaluate this, I'm going to change it to radical form. Okay? So the 2 goes there. 36 to the 3rd goes inside. Stay up. Let's go. Stay caught up. Yeah, I will in a second. Okay, this one, I'm going to put it over 1. Okay, now it's power and power property, and I'm multiplying fractions, so what rule can I apply here? Cross simplification, right? The 2 and the 6 have something in common. Now all I got to do is just multiply 3 times 3, which gives me 9. Okay. Now in the first part, grab your calculator. Okay, make sure you get to second quit. Get that clear screen. What I want, if I have a 2 in there, okay, all that means is that it's what? It's square root, right? Okay, so it's the same thing as just this square root symbol on your calculator. Second, get your radical on there. Hello, you guys watching? Get your radical on there. I'm going to type in 36, and then I'm going to raise it to the 3rd power, just like so. Make sure that you bring your cursor all the way out from underneath the radical. And then it just hit enter. Okay, so your answer on here is going to be 216 p to the 9. Okay. Okay, solve each equation. What I got to do here you remember, is I'm going to treat the radical, everything that's with the radical or underneath the radical, okay? I'm going to treat it like a variable. Everybody understand? Okay, so if I'm going to treat it like a variable, I'm going to move everything away from it. So what can I move here first? No. Move the 3. Okay, that gives me 3 equals. Okay, now, how do I get rid of a radical? Square. Good. Very good. Because the rule is, if I do something on one side, that's going to give me 9 equals p minus 2. Add 2. 11 equals p. Now it also says to check for extraneous solutions. Okay, because what happens, what can I put in front of a radical sign? What actually goes in front of a radical? Plus minus, right? So the negative may work, but the positive doesn't, or the positive may work and the negative doesn't. Is everybody clear on that?
Yeah.
A lot of it all depends on how much is inside, and then what do you have that's with it. Now in this case, if I plug 11 back in there, what's 11 minus 2? 9. What's square root of 9? 3. What's 3 plus 3? So it works. Right? Okay. On this one, can I move anything? I can square it, and I can square it. Put a 1 in front of that, 1 in front of that.
Plus b is minus 1.
Okay, grab your calculator. Okay, so on these, I'm going to go to my y equals button. There's one right behind you. Yeah. Okay, so to sketch the graph of each function, I'm going to go y equals. Okay, now on this one, I'm going to hit second square root, hit the x button, plus 3, bring it out, and then graph. If you have a hard time seeing your window, then just go to the table and then plot some points. Now notice this right here, it says error. What does that mean? Yeah, it's not going to go any further down than -3 and 0, right? Okay, so if I'm going to graph this, my first point is -3 and 0, which is right there. And then my next point after that would be what? -2 and 1. Which is right there. -1, 1.5, 0, 1.7. 0, 1.7, and then 1 and 2. And then what happens to my line? My numbers start to get pretty close together, don't they? Okay, so at this point, I'm just going to go smooth line, just like that. Okay. What would your x-intercept be? It'd be what? -3, wouldn't it? Okay, now, if I'm going to look at the calculator, how would I know to find, yeah, y has to be what? 0. I'm going to find the y-intercept. Which coordinate has to be 0? The x. So I can go to my calculator. What is it?
1.7.
Guys following? Okay, on the next one. Okay, so first number I want to type is 3. Okay, then I want to hit my math button. And then which number would I put now? No. 4. So you can either scroll down using your cursor and hit enter. Okay, or I can hit the number 4. And that should pop up. Now it's just x plus 5. Make sure you bring your cursor out. On you guys on the 83, you may or may not have to put it in parentheses. Okay, and then just hit graph. Voila. If you need to plot some points.
Wait, can you go back to what you got? Okay, just making sure I got the same movie things.
If I need to graph it on the graph, or you need to match up some points with yours, with your answer choice. Okay, so my first, and I'm going to use points that are, like right in here. -6 and 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. -7 and 3.78. We got right in there. Go up to -5 and 0. -4 and 3. -3. 3.7. And then it starts to flatten out a little bit, so just like so. The main thing is you can, does it have an x-intercept? -5 and 0. Y-intercept? What was it? 0 and 5.1, 5.3. Everybody understands what the y-intercept is, right? Right there. That's the x-intercept. Okay. Same thing. Just graph it. Okay, 2, math. Hit 4, cube root. And then x minus 2. Make sure you hit it, bring it out. plus 2. Graph it. Okay, so looks like you got a y-intercept there and an x-intercept there to know for sure. And all we're looking for is the x-intercept. So which coordinate has to be 0?
Y.
Y,
So
good.
it's 1.
Okay, so y is 0. So yeah, gotta be 1.
That's it.
Yeah. Okay, okay, math. Let's go down to 4. Okay, now look at this one. If you notice, is the -3 underneath the radical? Okay, so don't let that, make sure that you bring your cursor out, because it will change your graph if you put it under or outside. Looks like it's about 1, 2, -3 maybe. Let's check. Yep, there it is right there. Okay. Okay. What does this look like?
Fraction.
Fraction, good. Okay, so write this down. Okay, what was the number one rule that you cannot have with fraction?
Negatives.
The denominator or the bottom cannot equal 0. Right? Write that down. Okay, the denominator cannot equal 0. Okay, so this is what we call excluded values. Alright? Before you do anything, before you simplify, okay, find the excluded values first. And the way you do that is you take this, set it equal to 0. Alright, because it cannot equal 0. So what number can I plug in for V? It's not gonna work. 3. Okay, so I'm going to say V cannot equal 3. I don't even care about the top. All that matters is the bottom. And actually, the numerator can equal what? 0. You see what I'm saying? Okay. The reason why the denominator cannot equal 0 is because essentially it's not a value. Okay, so you can't divide by no value. That's why you have the rule. Everybody clear? Alright, so once I get done with this, okay, what can I do with this top part? I can factor it, right? What's its leading coefficient? 1. So if it's a leading coefficient of 1, it makes it pretty easy. Parentheses, be there, be there. Right, good. Do my tree. 12 goes there, -7 is there. Parker's saying -3, -4. She is correct. B minus 3 goes there, B minus 4 goes there. Riley, put that phone up before I take it away. I shouldn't have to sit here and keep warning you guys about that crap. B minus 3. What can I do now? Okay, so your answer is this. I also got to make sure that I do what? I got to include my excluded value.
Oh, so put that in the box.
That's what'll end up probably happening on your multiple choice test is they'll probably say b minus 4, and then they'll say the excluded value. Okay, well, is this correct? No, this is wrong. You see what I'm saying? Okay, so you just got to make sure that they have, part of it may be right and the other part may be wrong. That's what you got to figure out. Just be careful with that. Everybody good? Or do you need more time? All right, simplify each expression.
That's 0.
Yeah, so multiply fractions, I can apply my cross simplification rule, right? Okay, does these two have anything in common? Now it's not going to equal 0. It's actually going to equal what? 1. Okay, what about these two? It's going to be 1 also, right? 1 times 1?
1.
1 on the top, 1 on the bottom, which equals 1.
I hope it's like this on the test.
Yeah,
Dang.
it's that simple. Look at 16. Okay, we don't divide in algebra. What do? By its.
Wait, why don't we divide in algebra?
Well, I mean, you can, but you're going to end up multiplying anyway. It's like the subtraction rule. Do I subtract? The rule is basically you're going to change that to a plus. You're adding the integer. Make sense? So, I mean, you can say you're dividing, but essentially what you're going to end up doing is multiplying by its reciprocal anyway. Okay? So 5, change that to multiplication, and I'm going to flip. Okay, can I cross simplify?
N minus 7 and 5n plus 15 equals 7, or does it matter?
Why would it change to n minus
I
7?
don't know. A lot of times when we switch things, it just changes the sign. Plus 7 over 9.
Okay, so I can 1, right? Okay, can I cross out the n's here? No, why?
Because it's not
Attached to 9.
Exactly, good. It's attached to a binomial, right? And then this one's a monomial, right? Okay. So that's as far as I can go.
So you just forget about the ones?
That was on the
Well, what's 1 times?
Huh?
You asked, do you forget about the 1?
Yeah, when you cancel out the,
Well, I mean, what's 1 times that?
that.
That. There's no reason to put the 1s, right? Okay. Hello, stay with me. We only got a few more. I mean, we got like 42. I need to get through at least 25 today. Okay? Okay, so on this one, we're adding. When you add fractions, what has to be the same? Okay, in this case, is it the same? Okay, so make you one big line. I'm just going to put that on the bottom since it's the same. And then these two, notice you got a plus sign, right? Okay, so it's going to actually be a plus 4. So when I write it, I just write it like that. Okay, now the next thing you need to check for is if you can do what? Combine like terms, right? Do you have any like terms you can combine? You're done.
That's our answer.
Okay? Now, again, understand something. What can I do at the top here?
Flip things around.
I can rearrange. I can go. Still the same thing. Right? I can put the 4 in front. Still the same thing. You just got to make sure that the sign in front of the number or the variable follows it wherever you move it. Hello, you guys with me? Or should I go ahead and stop? Or, because I'm losing a bunch of you guys. It's only like 2 or 3 of you there. Okay? That's good. You're with it. Okay, what about 18?
You just.
Well, what I gotta
No,
find.
you have to
Common
make the
denominator.
denominator the same.
Okay, what's it gonna be though?
I forgot how you did it.
Okay, now, remember what I said, don't combine it until the last. Yeah. When you're gonna write it out, write it as 4, like you're gonna multiply those two. And the reason for this is because I gotta modify each one of these, right? Okay, how much do I gotta modify this by? Well, it's got a 4, what does it need? So I'm gonna have to multiply it by 6xy. Right? I mean, yes. Okay, now what property does this turn into? Very good. So 6 times 2, x times x be x squared, and then just bring your y. Bring my plus sign out, 6 times 3, and then x, y squared. Okay, now what do I gotta modify this by? What does it have? So what does it not have? What Parker's saying, multiply by 4, right? 4 times that gives me that. 4 times 5 gives me. Now, watch carefully, because you're not done. Multiply that times that. Okay, can I cancel anything out? Can I cancel, Millie? Get off your phone. Put it up.
X and Y.
There now, it's attached. Well, it looks like you're on your phone. Are you on your phone? It's okay, relax. Just don't be a drama llama, okay? Looks like you're texting on your phone, okay? Can I cancel any X's and Y's out? Huh? They're attached, aren't they? Okay, so I can't cancel them out. Alright, but, watch this. Can I reduce? Most definitely. And what I mean by that is does 12, 18, 20, and 24, do they all have something in common?
6.
6 won't go into 20.
Oh, yeah, it's like 4.
4 won't go into 18. 2. Okay, so 2 will go into 12. 2 will go into 18. 2 will go into 20. 2 will go into 24 12 times. That's what your answer is going to end up looking like, right there. Okay, even though it looks just like that, I mean, they're both equal, but they don't look the same. You guys got it? Okay. Subtraction. Still got to do what? LCD, which in this case is going to be, okay, again, don't multiply them together just yet. Okay? Something else that I would recommend, hello, you guys watch this, pay attention. You got a minus sign between them. I would change it to a plus, and then make the 5 a negative. You got to do that. It's going to jack your whole answer up. Okay? How do I modify the first fraction to have this denominator? Multiply by 3 over 3, right? How do I modify that one to get it 5u? Okay, so 5 times 5 will be negative 25u. I can go ahead and multiply those.
Why could we do it? So multiplying the 5.
So you know how to modify it. I mean, so if you can see it, I don't care if you do it at the beginning.
Yeah, I kind of like this.
I'd wait till the end.
Okay.
That way you can see exactly what you need to multiply by. That's just me. I mean, I don't know.
Well, it can be reduced to
Exactly, good.
by 5,
So 5 will go into 15,
3,
5 will go into 25,
5,
5 will go into 15,
3.
and that's it. Can I cancel the u's out? No, because it's attached to another term. Don't get confused with the reducing and canceling out. Don't get confused with that. Okay? Okay. On your paper, I want you to write this down. Anytime it's asking you to solve it, like this, you're going to have to, at the end, you're going to have to apply your zero product property. What is zero product? Yeah, just basically you're setting it, whatever your finished product is, you set it equal to 0. Write that down. 'Cause these problems like this are going to be probably the hardest. Okay, so the first, what I need to do here is I'm going to take care of that side first and simplify it. Same thing over here. I'm going to simplify that first side first. Hello, stay with me. Pay attention. What's the common denominator here? Okay, so I'm going to make one fraction, put that underneath, and then I can just attach the plus to that and combine like terms. Right? It's not multiplication, it's addition. So 4 combined with 3 gives me 7. Bring back my 1m squared. Okay, now what does that look like? We got a fraction equal to a fraction. How can I solve? What's that end up being? A fraction equal to a fraction is a ratio, isn't it? How do I solve ratios? Cross multiply. So this times that times that, I'll put that in parentheses, I'll turn it into distributive property. 1 times that,
This
n squared times m, m squared times 7. I gotta get like terms, so I'm gonna say now that gives me my what?
extraneous solution.
No, it's not extraneous.
So,
Not yet anyways.
zero pro. Oh,
That gives me my zero product property. Well, we'll talk. Okay, so zero, we'll find extraneous here a little bit, alright? Alright, so now I've got m3 plus 5m squared. Okay, now what do I have to do with this now? Yes.
Equals 0.
It's already,
Now I gotta factor that. We're applying zero product property here. Okay? 0 equals, what can I take out of both of those?
M squared.
What's that leave me with?
M plus 5.
M plus 5. Okay, now I could go m squared equals 0, which basically end up being what? So that's one of your solutions, right? Hello, you guys with me?
Yes.
Okay. Now take that, set it equal to 0. Okay. Now listen to me very carefully. You always got to check. This is where you find your extraneous solutions. Right now we're saying that we've got two solutions here, 0 and -5. But based on what we talked about earlier, we've said that what cannot be in the denominator cannot be what? In any fraction. Okay, so if I put 0 in for that m right there, what happens? It's not going to work, is it? If I put it in for that m, what's going to happen? It's going to cancel everything out. Same thing here. So that is not going to work. That's my extraneous. Okay? Now, on your answer choices, though, what you need to understand, that won't show up on your answer choice. Okay? The only thing that's going to show up is the one that actually works. But understand one of your answer choices may be 0 and 5. Okay, well, that's not true. That's extraneous.
Let's do
Okay.
25 there.
So,
Let's do 25 problems there.
well, actually, I may try to get through 27 because these last ones are really quick. Is that alright?
What? So the answer to 21 was,
Negative 5. Okay. Find the vertical asymptotes. Now, I would recommend to put those in parentheses on all of them. Okay? Because when you plug it into your calculator, okay, you got to separate the parentheses with the division. Okay, so you got a line right here. Just a little bit bigger. You got a line right here. You got a line right here. And a line right here. Vertical asymptotes. How do I find them? Go to second table. What am I looking for? Errors. Where are the errors? The two errors. Where are they occurred? One at -2, and then one at 1. So what I would do is make yourself a note right here. Use your calculator looking for errors in which column?
It's the Y column.
The Y1 column. Write that down. Write it down. There's no reason why you should miss these. Okay, so what are my asymptotes?
-2 and 1.
Now, how do I write it though?
You write it,
Because it is a line.
you write it Y equals,
Now it's vertical. Which coordinate? If I put a whole bunch of points on a vertical line, which coordinate is going to be the same on all of them? Okay, so that's an equation for a vertical line, right? What was the other one? These are my two answers. Okay, what number are we on? 23? Okay, I'm gonna have to do this full screen. Okay, so the top number is 1. Okay, so you got a line on the top here, and you got a line right here. And it's asking for the vertical asymptote. Looks like to me it's going to be what?
0.
And now can I just say 0?
No,
X equals 0. Everybody clear on that? Okay, write that down. X equals 0. Okay. 24. That's not right, was it?
No.
Sorry. X. Okay, now in 23, it's asking for what? Or actually 24. 24 is wanting to know the horizontal. Okay, so horizontal looks like it's going to be,
0.
no,
It is.
it's not either.
Why?
It's right in between these two lines right here. The vertical asymptote is what? 0. The horizontal asymptote goes right in between these two lines. Hey, notice the 3's not on there though. Okay, so you're going to have to look visually on the graph to find the horizontal asymptote.
What do you
Wait, you
mean?
write
The only
that?
place it says arrow is 0.
Okay, but that's the vertical asymptote.
But it's in the Y part.
Okay, that's what makes it the vertical asymptote.
Oh, horizontal's that way.
There you go. Okay. All right.
Got you.
So would
The
you
problem,
Would you write this one with a Y? It's like a Y equal?
yes, y equals 3. Now, one way you can know is just like Makai's saying is the equation is going to look like what? Y equals, right? Okay, now, what do you notice? Look at, so I'm trying to find what all my y's. If you notice here, what happens? It starts at 1.5 and then 2, and then if you notice, it starts to do what? Well, it starts to, yeah, but they start squeezing down and getting closer and closer, don't they? Okay?
You gotta find one that.
If you notice, what is it not crossing?
2.
No.
Okay.
It crossed 2, it's not crossing what? What's it approaching? And I can keep going, and it's not ever going to do what?
Dang, the calculator's a lot faster than mine.
You see what I'm saying? So your horizontal asymptote has to be what, guys?
3.
It has to be 3. Did you see how I find that? Okay. Uh, 25. Make sure you're plugging it in your calculator and you're getting the same results that I'm getting. Okay, because I don't have any calculators to offer you for the test except for these 83s. Oops. So you got to make sure that you're plugging everything in right. Looks like to me about right in there. Okay, now I'm going to show you. I'm going to explain something to you real quick. Listen to me very carefully on this. If you're looking for horizontal asymptotes, what's the highest degree on the numerator? It's 1. 1 to the first power is 1, right? What's the highest degree here? 2. Okay, now when the degree on the bottom, listen to me carefully. Hello, wake up. When the degree on the bottom is higher than the degree on the top, the horizontal asymptote is always going to be 0. Everybody understand what I just said? You may want to write a note, make a note. When the degree on bottom is higher than the degree on top,
So we can equal
it's
to.
always going to be 0. That's the horizontal. You understand? Don't get that confused with the vertical. It's easy to do that. Okay, 26. Okay, put parentheses around those two. Okay, now what's it asking for? The x-intercepts. Okay, so what do I know about x-intercepts? No.
Where they cross the horizontal.
-1.
They got to cross which axis? Okay, so if it's crossing the x-axis, which coordinate has to be 0? So now all you got to do is go to your second table.
Net, you have to go down to -1.
I'm looking for what? Let's see if I can do it like this. What is it? -2. What is -1 here? Well, yeah, but what? That's the asymptote, right? Is there another one? Look at my graph. Nope, I've only got one vertical, right?
So would that one be y too?
No, the vertical is what? X equals, okay, -1. Okay, 27.
X equals
I understand you're not checking asymptotes. We're checking for what?
intercept.
Intercept. So I need to plug it in. I can't follow the rule I just explained to you. It's just a different rule anyway. Is there an x-intercept there?
What is it? 3.
Okay, now think about what the rule that we just talked about. If the degree, listen to me, if the degree on the bottom is higher than the degree on top, then the horizontal asymptote is what?
So that works.
Y equals 0. Right? Now listen to me carefully. I'm trying to which means that if my horizontal asymptote is y equals 0, that means that these graphs they're going to do what? Hello, listen to me.
No.
They're going to approach the asymptote, but they're never going to do what? Cross it. So if the x-axis is my horizontal asymptote, okay, and if I establish that in this graph, neither one of these are never going to cross that asymptote, then there's no way it can have a what? An x-intercept. Okay, so what my answer, and here's what you have to be careful of, is finding the x-intercepts. Would my answer be 0 there? It wouldn't be 0, right? Because that's an actual number on the number line. What do I have to say then? None. Or you can say NA. NA stands for what? Available. You guys understand? Let's do one more and then we'll be done. Because it's easy. Okay, it's just wanting to graph it. So y equals, clear it. There you go. Now, if you need to, you can always do what? To help graph it, you can always go to the table and then plot those points. You got only one vertical asymptote. That's going to be at 1 and 0. You got a y-intercept there, 0, 1.5. I think that's the only line that crosses the y-axis. You got an x-intercept, -3 and 0, or 3 and 0, I'm sorry. Now, I want you guys to look at 29 through 38. Can you guys do those on your own? Because we've talked about that.
Yeah.
35, 36, 37, 38 is all the stuff we did yesterday. Okay, 29 through 34 we did like the week before. When we had all the snow days. 39 and 40, super easy. You can use your calculator for those two. Hello, you guys listening? You can use your calculator for those two. And then you just got to find certain values. Okay, look at 40. If it started at 40,000 and it doubles, how much would that make the population? 80,000, thank you. I always got to ask. You always got to go.
Because I drink a lot of water. I'll stop drinking water in this hour. I just try to stay hydrated.
Leave your phone with me.
I do that, bro. I'm waiting for it to go.
Just leave the phone with me.